Okay, y'all, let's do what? Section 1.4. Limits at infinity and infinite limits. Okay, those are two different things, by the way. This right here is going to be an infinite limit. We're taking a limit towards a number. We're going to get either positive infinity or negative infinity. How do we do this? Well, let me write it down. Aye. Sorry. All right, here we go. It was the limit as x goes to 5 from the right of 3 minus x over this polynomial. Super. Well, let's just always have the same strategy. And that strategy will be to factor and make our sign chart. So that denominator is a perfect square. And here is our factored form. Then my partition points are 3 and 5. And I can't just alternate the sign in each of these intervals like I do sometimes in class. I'm going to need to be more careful. See, it's not going to alternate around this one. Right? There's not going to be any alternation right here. And that's because of the even exponent. 0 is a good test point. That is what happens on the left side of 3. And if I put in 0, then that numerator is positive. And then if I put in a number like 4, I ought to get something negative here. Let's see. Sure enough, if I put in 4 right here for x, the numerator is negative. Meanwhile, the denominator is still positive. So really the only change happened right there. The only time it switched. Then this is the behavior of this function. If this is the function f of x, and this is how it behaves with respect to being above the x-axis or below the x-axis. Okay, so what's their question? Is there a limit? What's the limit as x goes to 5 from the right? Well, here's 5. And this is from the right. So I know that it is negative. So it's either going to be negative infinity or positive infinity. And it must be one of the infinities because as x is going to 5, this denominator is going to 0. So this limit is minus infinity. Ooh, and then they got another one. Determine the infinite limit. Okay, this is the limit as x goes to 5, the two-sided limit. It's still minus infinity. And the reason is because both of these are negative. If I come from the left or if I come from the right, I'm still going out to minus infinity. Okay, determine the infinite limit. This is the limit as x goes to 0 from the left of x plus 3 over x to the 5th times x minus 1. Super. It's already factored. My partition points are minus 3, 0, and 1. Really, I don't even need to find the behavior of this thing in every interval. I really only need to know how it behaves in this interval, because that is the interval that approaches 0 from the left. A test point in there, a good test point in there to use would be -1. If I put -1 everywhere in for x right here, I would have a positive over a negative times a negative. So it is positive in this interval. And since the denominator is going to 0 right there, because I would be putting in numbers very close to 0 for x, the denominator is going to 0, and so it's going to one of the infinities, and it must be positive infinity. Okay. Great. Now they want to know the two-sided limit. Oh boy. Well, good thing I still have all of my work here. What then is the behavior in this interval? I think it's going to switch, right? Because numbers in this interval are positive numbers, right? And we haven't made it to the 1 yet, so this term won't switch, right? Take a number like 1/2. Then if you take a number like 1/2, then you're going to have a positive numerator, and the x to the 5th will be positive, and 1/2 minus 1, that's negative. What did I say? Did I say it was going to switch or not? I don't remember now. I think I actually said it wouldn't switch. I guess I was wrong. Or maybe I said it did. I can't remember. Anyways, it switches. Now the sign is negative, so the limit as x goes to 0 from the right of that function, blah blah blah, would be equal to minus infinity, which is different from what this was. This was just infinity, and so the two-sided limit does not exist. Yippee. All right, compute the following limit. Oh my goodness. It's a big polynomial. The limit as x goes to minus infinity of minus 6x to the 4th plus 5x cubed minus 3x squared minus 5x plus 1. We are going to minus infinity. This big polynomial, whatever its end behavior is, out on the left side of the graph, it has the very same end behavior as the limit as x goes to minus infinity of minus 6 x to the 4th. This leading term is the boss of this whole polynomial. It is this term that determines what the whole thing is going to look like out at infinity. You can get so far out towards infinity that these terms become inconsequential. So these two limits are the same. By your limit laws, this is minus 6 limit as x goes to minus infinity, x to the fourth. This is an even exponent. So when I start dropping in negative x's, that even exponent's just going to switch them back to being positive. So this limit would be positive infinity, but then it's multiplied by negative 6, so it's negative infinity. Okay, same thing here. We've got the limit of a big crazy polynomial, minus 3x to the fourth, plus some other terms. And I'm just going to literally write other terms, because it does not matter one iota what these other terms are whenever we are taking a limit towards infinity. This limit will behave exactly the same as the limit towards infinity of minus 3x to the fourth, which is the same thing as minus 3 times the limit as x to infinity of x to the fourth. That limit is infinity, but being multiplied by negative 3 makes it minus infinity. So overall here, our answer is minus infinity. Compute the limit below. Alrighty. It is a limit at infinity, and it is the function 6x plus 5 over a minus 6x squared minus 8x minus 8. Alright. Right on. What is our strategy? Our strategy is always to, I guess, factor, right? I would like to know, well, do I even need to factor here? No, I'm sorry, I don't. This is a limit at infinity. This is a limit at infinity, and so, like we talked about in class, you can determine what the behavior of that thing is at infinity by just looking at the bosses of these this rational function, right? Treat the, so do what we did. Gosh, here's what I want to say. So officially, we would just be, well, can I do this officially? I will pretend like I can. The limit as x goes to infinity of 6x plus 5 over the limit as x goes to infinity of minus 6x squared minus 8x minus 8. Okay, pretend that this is totally cool to do. It may not officially be okay because of that being infinity, but I'm going to do it anyways because it illustrates all you need to do. The limit of the quotient is the quotient of limits. Okay, so but now I'm looking at this limit here. That's the limit of a polynomial. So that numerator has the very same limit as just 6x. In fact, I can just, yeah, I want to write 6x. And the denominator has the very same limit as x goes to infinity of minus 6x squared. But this was, I think maybe in hindsight, I wouldn't have written this step. I think maybe next time I would just go from here to there. Right? Cancel the 6's, bring the negative out front. This is the limit as x goes to infinity, and then, so cancel the 6's, cancel the x's. X is going to infinity. This whole thing is going to 0. The limit is 0. But you knew that already because the degree of the numerator is less than the degree of the denominator. If you are just needing to say what the limit is or where the horizontal asymptote is, then really no work is needed. You can just look at the exponents. But if you are needing to demonstrate that it has some kind of horizontal asymptote, or if you are asked to evaluate the limit, then you need to show just a little bit of work. All right? So in this one here, on this one here, we will do the exact amount of work that would be expected on, let's say, a written test. So this is the limit as x goes to minus infinity, and it is this rational function minus 6x minus 4 over 8x cubed minus 6x squared plus x plus 4. You will want to say that this limit here is equal to this new limit of a completely different function, where all I do is take all those other terms and put them in the garbage can. These limits are equal. Well, now I want to do some cancellation maybe, right? Simplification. 6 over 8, that's 3/4, and it's negative. So a minus 3/4 out here, and it's the limit as x goes to minus infinity of 1 over x squared. Well, this part here will be positive. It's going, well, yeah, it's positive, but since we're going to one of the infinities, then this whole thing is going to go to 0. And we don't really care at this point if it's negative or positive. We don't care if it's going to 0 from underneath or from above. But we knew this already because this exponent was 1 and this exponent was 3. And the one on top is just not strong enough to beat the one on bottom in the race to infinity. So the one on bottom, quote unquote, gets to infinity faster. It gets bigger way quicker than the numerator, so that denominator starts to explode, and the numerator is a laggard, and then that makes the whole function get closer to 0 as x gets bigger and bigger. Okay, I think you know what I'm going to do here. I'm going to say limit as x goes to infinity of minus 2x to the 5th plus other terms. That's our polynomial. It has a bunch of other terms, but they are all weaklings compared to this dude when x is out by infinity. So What? So I would say minus 2 limit x towards infinity of x to the 5th. Super. The thing in parentheses is going to be infinity, and then times a minus 2 makes it minus infinity. The limit to minus infinity of this guy, it's infinity. How do I know that so quick? Well, first of all, it's a quadratic, right? So it's a parabola. Leading coefficient was positive. It's opening up. These are the other terms. Don't need them. This limit behaves exactly the same as this limit. And this is always positive numbers. No matter what x you're putting in, this is always positive numbers. And they just keep growing and growing, so this is positive infinity. I mean, this thing is an upward facing parabola, so as x goes to minus infinity, the y value here is going to positive infinity. What, kitty? Oh boy, the answer is 1. Right? This would be how we would demonstrate what the horizontal asymptote for this guy is. We would take a limit towards infinity, either one of them. We would take a limit towards infinity. Here in this case it's minus infinity. And my numerator looks like a minus 2x cubed plus other terms. And my denominator looks like a minus 2x cubed plus other terms. This has the very same limit as x going to minus infinity of just the first term over just the first term. Well, those are the same term. This is the limit as x goes to minus infinity of the constant function 1, which is 1. Answer is minus infinity. We're taking a limit as x goes to positive infinity, and the bosses of the numerator and denominator, the leading terms, you know, the ones that have the biggest exponents, whatever that limit is right there is the same as this one. All I did was take all the other terms and toss them out. Don't need them. They're not doing anything when x is large enough. Well, this would be the limit as x goes to infinity of a minus 4x over 3. You know what that is. That's a line. hope I said that it was minus infinity earlier. That's a line that goes through the origin, has a slope of minus 4/3. So as x is going to positive infinity, the y value is going down to minus infinity. Woohoo! We finished. All right. Hit me up if you got questions.